Okay, a review from yesterday. We're going to use our calculator. This is where I think that generally people do pretty well for the most part with finding the antiderivatives on the test. We're still at kind of that level 1, level 2. We're gonna look at more challenging antiderivatives starting next week. Maybe Friday we'll get to that as well. We'll see. But this is the part where people really seem to struggle. I get very few questions on it. So I guess as I look to improve in my teaching, I would just, I know that this can be confusing. It's not as simple as some algebraic structures. And so please ask questions as you go over these within your homework and on your study guide, so we can make sure that we get this right. This is where a lot of guessing and just nonsense happens on the test. Okay, this is where the grade goes bad. So all I can do is warn you ahead of time, and that's all I can do. So displacement. Do you remember from yesterday what we do to find displacement? Yeah, the integral from a to b of your velocity function. So if we take if we determine the integral of the velocity function, that will tell us the total displacement. Do you remember what we had to do differently if we wanted to figure out the actual distance that it traveled? Yeah, so I thought I put that box there. I didn't, so we'll just write it on top. If you want the distance, okay, then that's equal to the integral a to b of the absolute value of v of t dt. And that's really what we call the net change theorem. It tells you the overall change of the particle or the whatever you're working with over the course of that time frame. I'm going to do one more, which we added today, and that's the mean value of a function. If you wanted to describe how you find the mean of something, how would you describe that? Add them all up, the average, so you add them all up and divide by the total number. Well, in calculus, the way we add stuff up is we do this. That's how we add up a bunch of stuff, right? I mean, isn't that how we added up an infinite number of rectangles? But now I got to divide by the total, number of things I added up, right? And so how I determine that is I do 1 over b minus a. What is b minus a? The width of your interval, right? So b minus a, that's the width of your interval. So you're just dividing by that distance, and that ends up being the average then value of function. And we'll show you where that applies in terms of our context of our problem. So this is probably the most commonly asked type of AP question you see within your free response. So you guys are asking what kind of free response questions could you possibly see on the AP exam? There's really 6 that are most common. I showed you a few the other day. This is number 1. This is question number 1, and we will get to this multiple times throughout the year. Use your calculator for following problems. You really can't do it without the calculator. The velocity of a car is modeled by this function, where t is measured in hours and v is measured in miles per hour. Consider v of t over the interval 0 to 4 and let s of 0 equal 10. Let's start with that. 0 to 4 and s of 0 is equal to 10. Interval 0 to 4. Is anybody give me an idea of what they think 0 to 4 means? Yeah, 0 hours to 4 hours. So we're looking at the velocity of the car over 4 hours. Good with that? Second thing, s of 0 equals 10. So S means position. Position at what time? Position at time 0 is 10. So that means, you're like at mile marker 10 on the freeway. So anybody know what mile marker Albert Lee sits on? Right about 13. Mile marker. So every morning when I come down, I get off of mile marker 13 to be able to come here to school. Okay. Owatonna, anybody know? 41. She smirks. She smirks. She thinks it's hilarious. Okay. Here we go. It says, find the displacement of the car over the given time interval. How do we find displacement? On your AP exam, this is what you will have to write. I want to be clear. If you don't show the work that I'm writing down, they will not give you credit. And I will also say that none of my college professors would have given me credit either if I did not write down this. If you simply wrote down the answer, even though you plugged it in correctly, they would not give me credit. So you should write this down. 0 to 4. You don't have to write the entire function. Just write v of t. We know what v of t is. We'll save you some writing space. dt. See, they're testing. Do you understand that displacement is the integral? Let's go ahead and type that into our calculator. Make sure we're getting the right thing. There's Sam with a gun. Would be kind of fun if we had a bunch of different students with like a pretend gun. Like maybe tomorrow we could have Danny with pretend gun, but then we'd have a pretend gun in a school, and that might cause a problem, huh? Just a little problem. What if we made one? That probably wouldn't turn out very well either. Okay. 20 sine of x. Whoop, 20 sine of pi x divided by 2 minus 1. And should I be in degrees or radians? Definitely radians. You go into mode and you press radians. I can't think of a time on the AP exam that you would be in degrees. Just so everybody knows. All right, so I'm sitting in y equals. Let's look at the function. Let's show your smarts here. Anybody know the maximum y value that we'd be looking at? 20, thank you. The amplitude of the sine function is 20. Actually, it shifted down one, so 19 would be the max, but I'm going to have to adjust my window. If you try just graphing it right now, you're going to see that you won't see everything. Hopefully you have the insight when it comes that time on the exam to be able to go to this spot and say, well, what we're going to do is we're going to go in our window, and we're going to adjust our y min to, say, negative 25, and our max to positive 25, and table every 10, or a tick mark every 10. That way I can see the entire function. Now here's the other thing. What should our x values be at? From what to what? 0 to 4. So I'm going to go into my window, and x values, I'm going to go negative 1 to 6. That way I make sure I see everything, and that will give me an excellent graph of what I want to see. All right? Now, here's what's really important is that if you go out to 10, you're fine. But if it was, say your window was at 2, that won't be enough to be able to perform your calculations. So how do I perform that on my calculator? Good. Second, calculate. 7, or just type 7. Now what? 0 and 4. Press enter. And there it goes to work. It's incredible to watch it. It's fun to watch it. There it goes. And what do I get? You get negative 4. You must write it accurately to 3 decimal points. You can either just drop it off after 3 decimal points, or you could round. But negative 4, that's the displacement. Okay? Now, yes. It does start at 10. I'm asking the displacement, not the position. So let's go to Riker's question. If the displacement is negative 4, what's its position? It's located at 6. It started at 10. It was displaced negative 4 units. So its location at 4 hours is at 6. Everybody see that? We'll do it again when we get to the question because we're not there yet. Let's go to B. It says find the average velocity of the car over the given time interval. This is where people really struggle, so we're going to try to help you in, okay? Am I given the position function, the velocity function, or the acceleration function? Which function am I given in the problem? I'm given the velocity function. To find the average value of a function, we simply do this. 1 over b minus a integral a to b of f of x dx. That is our formula for the average value of a function. It says average velocity. We are wondering the average value of this function. Well, what is the 1 over b minus a thing going to be? 1 over 4. Integral v of t dt going from 0 to 4. Do we know what the integral from 0 to 4 v of t dt is? What is it? Yeah. I'm going to put a label on it. It says average velocity. How do we measure velocity in this problem? Miles per hour. Some of you will get used to the order in which the questions are asked, and you'll rely on that for the test. I mix up the order of the questions on the test. You have to actually know what the questions mean. Find the total distance traveled by the car over the time interval. How is distance different than displacement? Absolute value. Thank you. So I do 0 to 4 of the absolute value of v of t dt. Samantha is doing a great job of thinking about absolute value. However, she is ultimately incorrect. And so what we need to do is we need to go back into our function and go into y equals, and we need to type in the absolute value of that function. Do you remember how I grabbed the absolute value of that guy? Yep, you could use math, but I'm going to insert, okay? I'm going to insert, and I go to catalog in order to grab absolute value. Second delete, INS. INS stands for insert. It's also on your Chromebook. Okay, so if you, can I show you a trick? Okay, can I show you a trick? Because there's multiple ways of working around this. Okay, I'm gonna get rid of that, and I'm gonna take my cursor off of that guy. And some of you guys ended up with an actual absolute value expression. I'm going to go into y sub 2, and I will do my absolute value. So if you guys grab your absolute value, and in that spot, we want to place y1, don't we? How do we get y1? Bars, y bars, function, there. So now the function I want to use is in y2. It's just going to do the absolute value of y1. So now you understand why last year I started to teach you the bars option, correct? You're going to use it throughout this time. So I still got to wait. How do you? You got it? Samantha did a great job of identifying that the absolute value of -4 is in fact +4. However, that's not going to help us with the problem, is it? As I look at the graph now, let's see what we get. Oh, there it is. It stays right on top, doesn't it? Kind of bounces. It's kind of fun, isn't it? Like, it makes you want to graph more of them. And so we're going to second calculate what? Number 7. And our lower limit is 0, and our upper limit is 4. Yeah, it's a very challenging thing for your calculator to do. It's actually doing many Riemann sums right now, so it's adding up a lot of rectangles. It's tough. Now, those of you who have TI-84s and whatnot, you have more RAM than mine has. Mine doesn't have much RAM. So 50.993. You're a jerk. Okay. So this is a great question, and this will get you point on or off on the AP exam. So these are the two options: 50.993 or 50.994, because it rounds to 4, doesn't it? So you can either cut it off after 3, or you can round to the nearest decimal. So that's what they allow you to do. We have to put the label. We're talking distance. What have we traveled? Miles. Yep, we're talking distance, so we don't want to label miles per hour. You just have to put 1. You can put or, and the teachers will simply smile, and they'll be like, oh, well, somebody who actually knew what's on the AP exam is teaching the kids. Because I once taught this class without ever having done a practice exam. I never knew. Yeah, well, they have a general idea. Yeah. Okay. Now, let's go back to my friend, Mr. Riker's question. Let's make sure that we get understanding here because we had questions popping up. We said that if I'm at mile marker 10 and my displacement is 5, where would that place me? 15. If I'm at mile marker 10 and my displacement is -2, where would that put me? 8. So the way we figure out position is we take your start and we add it to your displacement. So I want to do 2 hours and 4 hours. So I'm going to find the position at 2 hours. So I take the start. What's the start? Where's our starting location? Our starting location is 10, and we're going to add that to how do we determine displacement? Integral 0 to 2. Thank you. We'll do the 4 one in a second, but right now we're going 0 to 2 of v of t dt. Now, if we do set up the other one, we have 10 plus 0 to 4 of v of t dt. And in this situation, you know that 10 plus 0 to 4 of v of t dt, you know that the integral comes out to be what? 10 minus 4 is going to be 6. So that's where it's currently located. Okay, it's located at the 6. Yeah, so what we're going to do is we got to go back to our calculator now. Now, let's go back to our calculator. Do I want to use y sub 1 or y sub 2? I want to use y sub 1. So we press enter on that, and we take this bottom one off. So I'm focusing on y sub 1. Why did I want to use y sub 1 and not y sub 2? Y sub 2 is absolute value, and that refers to distance, whereas no absolute value refers to displacement. So that's really one of the key things you're trying to learn today, folks, is that absolute value is that distance, and non-absolute value is displacement. And that will get you points on the test without a doubt, and points on my test too. So I go to second calculate, and I choose number 7. And this is where you just pay attention to detail because we got a lot of things going around. But where am I going now? I'm going from what to what? 0 to 2, because I already have the 0 to 4. So we'll go 0 to 2. And it's going to run that guy right there. And I get 23.464. I like to just cut it off. I don't like to round. I feel like I make less mistakes that way. So I have 10 plus, what do we get? 23 point what? 464. So that would be 33.464 mile marker. So I'll just put MI for mile instead of the mile marker, we'll say. How are you feeling? Is it, not too bad? Okay? Horrible? I made it 0 to 2 because it's wanting a position at 2 hours. Is that better? Thank you for asking the question, Ishika. Way to be a star person. So I got an idea. Let's do one question, which is going to be the easiest stinking question that you're going to see. And then we'll do one more that's more difficult. This one, letter E, is so simple. It says find the acceleration of the car at time 2 hours. Well, you tell me, how do I determine acceleration? Derivative of velocity. So acceleration at time 2, and we're practicing because this is actually what you'll write on the AP exam. You'll say acceleration at time 2 is equal to the derivative of velocity at time 2. So this way, the people that are grading the AP exam are like, oh, I know what they're doing. They're actually saying that there's a connection between acceleration and velocity, and I bet that they're going to do that operation on their calculator. And I'm saying, thank goodness this is a calculator problem. How do I find derivative on my calculator? Second, calculate. 6 is derivative. At what time am I finding the derivative? At 2. Negative 31.415. What is my label? Yeah, Acceleration is miles per hour squared. Last example here, okay? And then you'll be set to kind of work through these pieces. And now this one's definitely more challenging, or I'm going to do my best to try to make it easy. This is where it falls apart, okay? It says, what is the average acceleration over the time interval? Now, this is similar to what other question? Letter B. And what makes it similar to letter B? The word average. So this is how I'm trying to tell you the difference between these two questions. This is my goal, to tell you the difference between the two questions. For a function, are you given the position, the velocity, or the acceleration? You're given the velocity. Is this asking for average velocity? No. You see, you use this guy when you're asked to find the average value of the function you've been given. Have we been given acceleration? No, we haven't. We haven't. So therefore, we don't use this. So what do we use? Well, what else allows us to find average rates of change? Average rate of change. That's all we're looking at, because how does acceleration compare to velocity? It's the derivative. It's a rate of change. So if we want to find an instantaneous rate of change, we use the derivative. What if we want to find an average rate of change? The question says, what is the average acceleration? You're thinking that if it said the actual acceleration, which is right here, that's where you do derivative, because acceleration is a rate of change. Well, here it's saying acceleration, so you think of rate of change, but it says average, so therefore we use slope. That's how you tell the difference. Somehow you got to get yourself to tell yourself that, and then when you do the assignments, see if you can predict what you're going to use when. So average acceleration over the time interval, well, the time interval is from what to what? 0 to 4. So we're going to find v of 4 minus v of 0 over 4 minus 0. Which is just y sub 1, I'm sorry, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? So we know what we get on the bottom. What do you get on the bottom? 4. So let's do the top. And so we're going to use another command function on our calculator. We're almost done here. I know we're very close to time. So what's a nice way of calculating v of 4? Using my calculator. Table. Sure, go to table. Table, and I can type in 4. I get -1. Type in 0, and I get -1. So you get 0. It's going to ask for a label on the test. Acceleration, we'll measure it in miles per hour squared. Excellent. You're now prepared to work through those type of problems on your worksheet. Tomorrow we have our last day of going through these types of problems. We're going to look at a couple tables tomorrow and graphs, and that will be it. And then Friday we'll be ready to move on to other stuff. You definitely want to make sure that you're making some progress with this. This is the worst part of the test for people. And trust me, we'll do a checkpoint on it, but that's about all we'll be able to get to. Good job today, folks.